Mm. Okay, so good morning, everyone. We start today's lecture on time. I hope all of you can hear me lah. But in case if you cannot hear me, then you try to uh, send me a message lah, or you turn on your microphone, then you let me know in case like if something goes wrong, or you cannot hear me, or you cannot see the lecture slide. I hope you can see the lecture slide. Okay, so we start today's lecture. So I just skip the few slides at the beginning, which give you a short introduction about myself. I believe during the last lecture, you know already my educational background and also my research expertise, right? And this slide is just a quick review or revision about what we have learned during the last lecture. So you remember in the last lecture, we have studied the history of AI, and in particular, we have studied the nature of AI 1.0, AI 2.0, and the AI 3.0, right? So I hope that you could still remember the nature of AI 1.0 is about the machine thinking, right? So then you know that at that time, the pioneer in AI domain or were very ambitious, right? So they directly jump into this objective of achieving thinking machine, all right? But obviously, if a machine is not able to learn, how could a machine to think, right? This is why we have AI 2.0. The AI 2.0 is focused on machine learning, right? So then people try to make a machine to learn, all right? Then immediately you understand if a machine does not have innate intelligence or innate capability to transform signal into physical knowledge, then transform physical knowledge into conceptual knowledge. How could a machine to learn, right? So this is why the true foundation of AI should be AI 3.0, which start with the development of machines self-intelligence, or in other words, a machine must have innate intelligence in order to be able to learn, in order to reach the level of undertaking thinking, right? Then this slide basically summarizes to you what is a blueprint of AI 3.0, right? So from this slide, try to remember these four numbers, 1, 2, 3, 4. One means AI has a one tool. This tool is human language. Now you understand the importance of human language, because with the use of human language, any human being is able to learn any new knowledge, right? So for machine, they must also leverage on the use of language in order to learn something new, right? So one means one tool. This tool is language. The two means there are two words, right? One is external world to the machine. Another is internal world inside the machine. It's like a human being, right? We have external world. We also have inner world or internal world, right? But here we use the terminology of physical world and the conceptual world, right? Physical world means it's external world to any machine, to any human being, right? But conceptual world means internal world, which are being described by the use of language, okay? So that's about these two. Three means there are three types of intelligence, right? The first one refer to human intelligence. For human being, we have intelligence. I guess all of us know, right? The second intelligence is computer-aided human intelligence. So we must pay attention to this second intelligence. Okay, so far in the past decades, okay, in the history of AI, a lot of research work and a lot of courses are dedicated to computer-aided human intelligence. All right. Then the intelligence should be machine intelligence or artificial intelligence. All right. So these are the three different type of intelligence. Okay. Then from the viewpoint of general public, we would like to achieve machine intelligence, right? Then you need to pay attention to this number 4. There are 4 pillars which will enable us to make a transition from achieving computer-aided intelligence to machine intelligence, right? So here you see these 4 pillars, right? Pillar number 1 is about the knowledge representation. Pillar number 2 is about the knowledge perception. Pillar number 3 is about the knowledge computation. And the last pillar is about the knowledge application. And so far, you know that we are very strong in building up pillar number 1, 3, and 4. The weak pillar is pillar number 2. So this is why we need to spend more time, more effort to strengthen pillar number 2, which is about the knowledge perception, all right? And these are the 4 numbers which will help you to understand the nature of AI 3.0, all right? But in terms of knowledge flow or signal flow or data flow, actually AI include 3 transformation. So it's quite simple. The first transformation is the transformation from a sensory signal to knowledge. So you see this terminology of phase, which stays signal to knowledge. But the first signal means a sensory signal, right? This is the first phase of a transformation. The second transformation is about the transformation from existing knowledge to new knowledge or knowledge in other domain, all right? So that is the second phase of transformation. Then the last phase of transformation is the transformation from knowledge to motor signal. The last signal means motor signal, okay? So with the use of a motor signal, then a human being or machine or robot can take action, right? So if you remember these 3 phase inside the pipeline of transformation from signal to signal, because the starting point is a signal, the ending point is also signal. But pay attention, the first signal refers to sensory signal, and the last signal refers to motor signal or control signal. All right. So this is a summary about what we have learned from previous lecture, right? Then today we are going to study some typical or popular application with the use of AI, and then you will be able to understand. In order to develop or design intelligent machine or intelligent robot, we must pay attention to the outer loop of autonomous behavior or autonomous action. For those of you with control background or with a little bit of knowledge about the control theory, you will remember that in control theory, we are doing the study of knowledge and the technique about the design of inner loop. The inner loop basically consists of sensor, controller, and the actuator, right? So that is the inner loop. So with the use of an inner loop, we can achieve the control of temperature, pressure, position, velocity, acceleration, force, torque, etc. Right? So these are the result of making use of inner control loop. But here we talk about the outer control loop. The outer control loop include perception, planning, and the control, right? Okay, so besides this intelligent behavior, then another impressive application with the use of AI is design. If you look at the human being, the highest level of our mental activity should be the design, right? But design is in a broad sense. For example, when you compose music or compose a text or article, this is also a design process, right? Design does not mean you are going to design a table, design a useful product, right? So compose music or compose a poem, etc. These are also related to the mental activity under the category of design, right? So design actually refer to the highest level of mental capability of intelligent system, intelligent machine, or eventually for human being as well, right? Okay, so this will be the key takeaway from today's study. So I try to showing you 6 typical scenario of AI integrated application. And these 6 category of application actually are grouped into 3 group, right? The first group is knowledge-centric application, right? Because just now I mentioned inside the blueprint of AI 3.0, there are 4 pillars, right? And today, pillar number 2 is a weak pillar, right? So we need to spend more effort to strengthen pillar number 2, right? So the first 2 applications actually refer to pillar number 2, right? And if you look at the human being, I believe last lecture I already mentioned, right? So actually we are like a fish. We are living inside the ocean of a signal channel. If we do a comparison between signal and the water, actually for human being, we are living inside an ocean of a signal. Then among all the signal, so you remember, the signal with the number 1 importance should be visual signal. And the signal with the number 2 importance should be audio signal, right? But of course, we have other type of signal. But here, I just showing you example of application which make use of visual signal and audio signal, right? The second group of application is related to skill-centric application. Because for human beings, we are very, very skillful. We can undertake a lot of autonomous and intelligent behavior. All these are skill-centric application, right? And lastly is about the creativity-centric application. So that refer to the design. Just now I mentioned to compose the music, to compose a painting, a drawing, or eventually a poem, etc. These mental activities are also related to design, right? And behind the design, okay, there must be a creativity there, right? Design does not mean copy, just blindly copy other people's work, right? So creativity must be there, or individual creativity must be there, right? So today we are going to go through or to learn some typical example which are related to knowledge-centric application, skill-centric application, creativity-centric application. All right. Okay, so let's start with the first category of example of knowledge-centric application. All right. So just now I mentioned we human beings are living inside the ocean of a signal. So we are like a fish, we are surrounded by signal. So without the signal, we cannot develop our level of intelligence, right? And this drawing actually highlight to you among all the signal, visual signal, audio signal are the two most important signal to human being and also to future machine, right? Then through the use of a signal, you see our mental capability are able to transform a signal into cognitive state of knowing the meaning inside the signal, right? And this slide basically highlight to you, right, the detail about the transformation from visual signal all the way to the knowledge hidden or encoded inside the visual signal. It's like when we open our eye, we can see a signal, right? And immediately we understand what we have seen from image or from the video or from the actual lighting emitted from a signal, etc., right? And from this slide, you can also see the coupling effect between visual signal and the audio signal. Why is this so? I guess all of you know when you read the book, right? When you open the book, actually we make use of a vision system to convert the light emitted from a page in order to capture or detect the text, right? So you see the text at the bottom, on top you see the image, right? So now you will see actually it's very interesting for us to know that we can also make use of a vision system, right, to obtain. But of course, we can normally we use our ear. We hear something, then we convert audio signal into the text. Then we understand the meaning inside the audio signal, right? But we can also use our vision. When we read the book, actually we convert the visual signal coming from the symbol into the text. So this is why vision and the audition are two mental capability which are strongly coupled together, right? Okay, so this slide help you to understand this coupling effect, right, or relationship between vision and the audition, right? Okay, and the output from our vision system should be knowledge. This is very, very important for you to know, right? Then you may want to know, how do we represent knowledge, right? And this is our proposition. So we believe inside our mind, we represent knowledge in this way, all right? So you see, we have elementary knowledge, that means the basic level of knowledge. Then we may also have composite knowledge, right? Or knowledge at the higher level, okay? And here then you see these two words. Do you see the physical world? You also see the conceptual world. Physical world means this is the outer world, right? Conceptual world means it's the inner world, right? Inside the mind of a human being or inside the mind of a machine, all right? This is very, very important. And then you see inside the world, we have elementary meaning. All elementary meaning are related. Now you see the definition of a knowledge is very important. If you go to search the internet, ask this question, what is a knowledge? I believe you will get all kinds of answer there, all right? And there's no consensus about even about the definition of a knowledge, okay? But here we unify this definition, okay? At the elementary level, knowledge refers to property, constraint, behavior of object. Very simple. This is a universal definition of knowledge, right? And then what will be the knowledge in the conceptual world? Because in the conceptual world, we have entity, virtual entity or symbolic entity, which is called as a world, right? And each world has also property, constraint, and the usage, right? So how to use the word, okay, inside a language, etc. These are elementary meaning or knowledge about the entity in the conceptual world and the entity in the physical world, right? And in the physical world, that could interact together. They can form a relation network and they can interact among the member, okay, inside a relationship, right? Then we have an interaction network. Then when interaction evolve over time, then we see the event. When related event evolve over time, then we see the episode, right? Then all the related episode actually consists of a story, John. If you even go higher level, then we have a story network. Then above a story network should be what? Should be the history. Now you see, when we talk about the history, if really we want to understand the entire history of a human being or human society, we must apply AI software or AI system. So eventually the visualization or recall or interpretation of a human history in future could be done, okay, by AI system. Today, we depends on human being to write the history, right? Now you understand what is the history. At the high level, history consists of related story. Then what is a story? Story consists of a related episode. Then what is the episode? Episode consists of a related event. So from the top all the way, we can go down to the lowest level, which consists of a knowledge about the individual entity like in the physical world, right? Then all this knowledge in the physical world could be projected into conceptual world with the use of a human language. Now you understand, okay, the two importance of this tool, which is a human language, okay? So I believe this slide is extremely important, and because of a lot of people do not understand this slide. This is why the AI research has a lot of issue, right? It's like today you may heard of a ChatGPT. Then what is ChatGPT? Actually, ChatGPT is trying to understand, trying to come out with something similar like this slide. But unfortunately, they venture into the wrong direction, okay? But their goal, their objective is right, but the methodology is wrong, all right? They deviate from this slide, okay? So this just help you to understand about the situation in AI. A lot of people still struggling about how to represent knowledge, okay, from the physical world, how to represent the knowledge from the conceptual world, etc. Right? Actually, this slide, I believe this slide provides the answer already, okay? And since today's lecture is not to teach you the theory, okay, about the vision, because if you want to learn what is the vision, at least you need to spend one semester just to know the detail about the vision, right? But today we only have less than 2.5 hours to cover many typical application. All right. So then I just showing you the result, the current result, which are achievable with today's technology and the theory, etc. Right. So this slide basically highlight to you today. Okay, our machine are able to construct geometric model from the use of visual signal and do some recognition of a pattern, okay, based on the use of visual signal, right? But for those of you who want to do research in AI, then you will see here I recommend two research topics for you to undertake, right, in future. One is about the image photo understanding. Second one is about the scene understanding, right? These are the two domains in which you could contribute in future, right? Okay. Then for 3D model acquisition, then this slide basically explain to you the hardware setup and the output from the system. And from here you will see we have a camera, we have a laser projector here, we have a rotating table, we have an object here. When this object rotate, we can match line by line all the 3D coordinate along the intersection line, okay, between the laser plane. So this projector will project a laser plane, and this laser plane will intersect with this object. This is why then you put all the coordinate together, then you will see a cloud of a point, okay, which belong to the surface of this object. All right. Then from this example, you will see the result is quite accurate. All right. So this is a system set up by us, okay, I guess more than 20 years ago, right? So almost 30 years, all right, okay. And here is a video which explains a little bit to you how to do the setup, how to do the acquisition of 3D coordinate, okay, along the intersection line.
So it's perfectly level and aligned. Level center alignment line together with a model platform. Second step, focus. Allocation totally line focus. On the mobile devices, as low as possible. This result sure, but years. This makes cutting easier. Enter the capture. Version of the software. Captions in order to bring this is the purpose of this. 5.4 increase degree and to minimize any laser reflections. Video frame.
This should be you to know how to make use of a visual signal to capture the geometrical model of any object. All right, and this slide highlight to you one of our research work, which is trying to remove the laser projector. In the previous example, you see we need to have a laser projector to create intersection line, all right? And then our intention here is to remove the use of a laser projector, just make use of a two camera. One serve as a virtual laser projector, all right? But we still make use of a rotating mechanism to construct, to compute the 3D coordinate of the point along a virtual intersection line, okay? And from here you see some intermediate result obtained from this method. And this method has received award from industrial competition, all right? This is an award-winning project, right, done by us. And I guess more than 20 years ago, right? Okay, it's just for you to know. And we can also use a single camera and then explore certain property of the motion, right? Then incrementally to build up another example, right? So you see, we incrementally of a single Okay, so this should be good enough. Then we in industry, quality control of product is very, very important. All right. Then how to control the quality of a produced product. But actually, quality may refer to many aspects of a product. For example, here we can see that we can make use of a vision system to make sure that the printed information on the surface of the product is accurate, all right? Because if we print wrongly the information on the product, then the user will use the product in the wrong way, all right? So this is very important for us to make sure the information printed on the product are 100% accurate, etc. Then you see we can make use of a vision system to do the verification about the accuracy of printed information. All right, so this is just this example. And this example showing you in future how to develop or how to achieve the scenario of a smart city. So it means in future, in the city, in the street, we may have a lot of camera, and all the camera can understand the meaning of activity, okay, undertaken by the passenger or by people, okay, in the street, etc. This should be good enough, right? Then, okay, this is one more example about the image understanding or video understanding, because in the production line and the conveyor is keep moving, right? So then we need to understand, okay, the content inside the production line, and eventually also to do the measurement about the geometry of the produced part, right? So this is for this kinds of industrial tasks, we can make use of a vision system to achieve, right? Okay, and then for the transportation, just now I mentioned, for one of the future scenario is a smart city. Another future scenario will be smart transportation system or intelligent transportation system, all right? So inside intelligent transportation system, smart car is very, very important, all right? But anyway, we will come back to the detailed study or lecture about the intelligent transportation system. And today, just I play a short video for you. Okay, so it should be good enough, all right? And for those of you, just now I mentioned, if you want to undertake research in the area of AI, and this slide basically highlight to you one important direction for you to venture into, right? So image understanding, scene understanding is extremely challenging task. For example, for you, I guess all of you can immediately understand this picture, Chana, all right? And inside your mind, you have a three-dimensional output inside your mind, Chana. But however, this the input from this picture does not contain any 3D information. There's no depth information, Chana. This is a 2D picture. But inside your mind, the output is a three-dimensional, Chana, all right? Then you can ask yourself, okay, how come we can produce a 3D as an output, but the input to our eye are 2D, right? So then we need to discover the mechanism or the physical principle behind such a transformation from a 2D image to 3D scene, all right? Okay, so this is a very, very interesting area for you to venture into if you want to do research, okay? But with such capability, maybe in future, the vehicle, okay, when you drive your car, the car can understand the meaning in the surrounding of a, okay? So, the vehicle can understand the street, okay? Okay, this should be good enough just for you to know, okay? With the use of a visual signal, we can derive a lot of useful information about the environment in which we are living, or about the environment in which the future machine, future robot are undertaking intelligent or autonomous behavior, etc. Right? Okay, so visual signal has a number one importance to human intelligence, but also to machine intelligence. All right. So after visual signal, the second important signal should be audio signal. All right. For human being, we leverage on our ear. We can understand okay, the meaning behind the speech, right? And based on such understanding, we can interact with other people, other person, all right? So in future for machine, we would like also to enable future robot, future computer, future machine to be able to undertake a conversational dialogue, okay, among the machine or between machine and the human being, etc. Right? So now you will see for the audio signal is also very, very important. All right. Just now I mentioned, so the visual signal has a number one importance. Audio has a number two importance. These are the two most important signal to human being, but also to machine, right? Okay. And now you see again this slide, okay? Because vision, audition are strongly coupled together. For example, we can hear the text, all right? We can also read the text, all right? So then once we get the text, then we want to know, okay, what should be the meaning behind the text, okay? So you will see the output from the use of a visual signal and the output from the use of audio signal are the same, right? So they are the knowledge, okay, encoded inside audio signal or knowledge encoded inside visual signal, right? Then they will face the same issue, all right? How to represent the knowledge encoded inside the audio signal. Then the solution will be the same, right? Because we need to know how to represent knowledge from the physical world, how to represent knowledge from the conceptual world, right? So we use the same methodology to represent knowledge, okay? So this slide, now you understand, is extremely important in AI, right? Okay. Then for those of you who want to do research with the use of audio signal, you may want to know, all right, what should be the direction for you to venture into. Actually, you see, one is about the machine translation, and another one is about the development of conversational dialogue, okay, which will enable computer or robot to undertake conversational dialogue with a human being, etc. Right? Then for machine translation, one challenge is to achieve a one-to-many translation in a meaningful way, right? Okay, so this is a very, very challenging research topics for people to venture into, right? If let's say some of you are very excited about doing AI research, then these two topics should be interesting for you to consider, right? Okay. Then what is a machine translation? I guess all of you may know, right? Even in China, we have a lot of dialect, right? Because people at the different area may speak slightly differently. Sometimes, especially in the southern part of China, right? If you travel from one province to another province, all right, then sometimes you may not be able to understand their local language, etc. Right? So if we have AI system which help us to do the automatic translation, then that will help us to communicate among ourselves, right? Okay, then this video explain to you the challenge, the issue faced by machine translation, all right?
A device that can instantly translate languages, so is it possible in real life? Already just a word, sentence, or book language into whether it's or meet the funds. Course syntax by identifying the change as and rest and a direct must unit. This is the word muffin and S plural. Finally, to semantics. What different elements actually mean? The program will refer to an target is where the machine and while doing so to make out. Also, and 3 using a you want to eating some particular program their finer such as children even which analyze that ready translated to text program can identify wrong phrases use the translation all unique will still give you the result. In interaction with people who speak them, to spur voices spectrum time is you might have
Okay, that video is very important for you to, if let's say you pay attention to the last part of the video. So basically it means if we follow the traditional way of doing machine translation, we will face a tremendous difficulty, all right? But however, within the framework of AI 3.0, it should not be that difficult, all right? Because from the video, they still talk about the old methodology of doing machine translation. This is why they still feel a tremendous difficulty there, all right? So that indicate to you opportunity for you to do research in this area, but use the framework of AI 3.0, all right? So that should be the message for you to capture. It's very, very important, all right? So that is opportunity for you to achieve something in machine translation, okay? But this another area is about the conversational dialogue because you know today robotics is also very, very popular. Then how to leverage the popularity of a robot in the society, in the industry, all right, to drive AI research to reach a new level, right? So this is another area for those of you, if you want to do research, right, then try to focus on the use of human language to achieve a conversation dialogue. But this just I guess see the if let's say you have understand or transform the into the text, then the text to a human being. Right? So we move on. And this is a recent scenario that we would like to achieve, right? In order to enable humanoid robot to undertake a conversational dialogue with a human being, right? Okay, and this is a project that we have done more than 5 years ago in China. Right? Good enough for you to know, right? How to enable a future robot to undertake a conversational dialogue, right? That should be a very important application of AI, which make use of audio signal, right? Then for industry, actually, today we have a voice-based inquiry system. This is also quite interesting to company, right? So then this video.
Wire First, you need option for can all give us a minute. Question is, they can use into relevant information for
How are you? That's Thomas.
He has more than you actually handle a volume of willing to increase the revenue of a business.
Okay, so it should be good enough. And this also a project that we have undertaken more than 10 years ago. This is also to develop or this is a project showing you the result of a conversational dialogue between a human being and the virtual robot. I just play a little bit just for you to know what is the scenario of application. All right. You see, there's a virtual robot there. Then through there's a communication robot user. Live from the way you see. This is live from the robot. The meaning and control the most because move is a deep of translation knowledge, right? To understand, right? Along the foundation, we can so to undertake this is a very scenario. No, okay, so it's good enough. Okay, so that's about the two category of knowledge-centric application with AI. So you will see the AI system make use of a visual signal and the speech signal, right? Then for skill-centric application, then you will see planning and the control are very, very important because these are the two important modules inside the outer loop of any intelligent robot. Okay, let's look at the planning. For planning, the typical scenario is a robot. Inside the robot, systematically, we must have a planning module. You see, motion planning. On top of motion planning, robot intelligence. Then from here, you will see the vision system and the speech system, etc. Right? So, slide highlight to you the blueprint of a robot. For those of you who have studied robotics, what is kinematics, what is the dynamics, what control, and eventually design plan module, right? Okay, and inside the robot we have controller, etc. Okay, so for those of you, if you have studied robotics, then this slide is a blueprint of a robot. At the beginning, I have mentioned, right? We have a group, and the list control loop. You see, sensor, controller, actuator. This is the control loop. Then we also have outer control. Here you see outer control loop, perception, planning, and controller. So you see this outer control loop from this slide. Okay. Then for planning is a very, very challenge mental activity, right? Because planning can apply to many other domains. Okay. For example, decision making is also a mental activity which are related to planning. In order to do the planning, we understand the description of the goal, available strategy for robot machine to undertake. Then the task for robot to perform in order to achieve the goal, right? The robot machine must know its own physical inner capability, right? So capability of the machine, available strategy to achieve, then sequence of a task which will enable the machine to achieve the goal, right? So all these answers must be provided by a man or the man of a machine or man of a robot, etc. Okay, so it's quite challenging mental activity for robot machine to undertake. But here I just show you a few examples which are related to emotion to action taken, right? But planning may refer action to undertaken by a group of robot, group of machine, group of people, like not just by individual machine, individual robot, or individual person. All right, planning is really a very, very challenging activity, right, which are related to AI. All right, okay. So, but for individual robot, it should be relatively easier. For example, to plan the sequence of a motion to be undertaken by arm manipulator, that should be easier, right? Then you see planning involve the determination of equation of the trajectory, right? This just help you to understand a little bit detail about the outcome of planning, right? And then this video highlight the scenario about transformation to motor signal, the instruction, plan the motion, execute the motion, right? So this scenario of transforming knowledge to motor signal, right? So people do the pick and you see pick the object and base it, right? Okay, so we move on. Then for grasping, also it's very simple example for a robot to undertake planning, but this also help you to understand the challenge, even for such a very, very simple activity, because we have a 5 finger, how to plan the motion of all these finger in order to pick up an object, etc. Right? And this video also help to understand this knowledge So that video really help you to understand the three basic process inside the pipeline of signal flow, data flow, knowledge flow, right? The last process is a transformation from a knowledge to motor signal. So that help you to understand AI 3.0, okay? Then for locomotion is even more challenge, right? Because for manipulation, grasping, there's no issue of stability. But however, to undertake a biped walking, stability is an issue, right? For human being, we have walking, standing, sitting, crawling, lying. All these are the sub-behavior which are related to biped locomotion, right? So this is a quite challenging task for a robot man to undertake. Okay, so let's give you an example, right, about the role played by planning in helping a robot to do manipulation, grasping, and biped locomotion, right? So, and in particular, these three examples help you to know that the last phase inside the pipeline of AI 3.0, which is about the transformation from a knowledge to motor signal, right? So then for the second category of skill-centric application is the control, right? If let's say we couple control with perception, right? And in the previous video, you see the planning control, right? Now we try to incorporate perception, planning, control together, right? Then you will see there are some interesting application, okay, which could be enabled by AI 3.0, okay? And from this slide, just now, you see plannings here. Now we focus on the control. Then you see the outer loop of robots control system involve perception, perception here, perception, planning, control. You see perception, planning, control. Then we close this outer loop, then robot can also achieve some autonomous behavior, right? It means more impressive, right? Okay, and then we can talk about okay, we can get the control of manipulation, grasping, and the locomotion, right? And eventually, we can also leverage on the use of audio signal to implement the control scenario of robot, right? And from here, you see the three basic module which involve inside the outer control loop, which include perception, planning, control, right? Okay. And then this is a typical setup of let's say the perception is a vision, and the planning is inside the brain, inside then control, then you take action, right? So this is just a hardware detail about the perception, planning, control loop inside a robot, right? And from here, you see we have a robot, and this robot only pick up a yellow part. This robot will pick up a white color part. So obviously, you see perception is important. Okay, perceives the color Then based on the color information, this robot know what to do, right? Then based on the color information, this robot know what should be his activity, right? So this is the typical scenario of again transform knowledge into control signal. For example, knowledge about the yellow color, knowledge about the white color, right? Then the corresponding control signal must match with information about the yellow color, information about the white color, right? So this is simple example help you to understand this third process inside the pipeline of AI 3.0. Okay, and this is okay, so you see, this is a typical scenario, right? How to implement this outer control loop, and this is a result developed by us more than 10 years ago, more than 15 years ago, right? Years ago. On the page motion. Okay, be good enough. And this video is quite long. I just play a little bit, right? This video was taken 40 years ago. Now you imagine important too much time left. And this is a demonstration done by us more than 20 years ago. Then from here, you see this is a vision guided view with the locomotion. Vision guided platform to by follow between the target, right? Here. Right? Okay. We are okay. And with such technology, and today you may see the deployment of a fully automated vehicle in industry. And this video showing you the application of unmanned vehicle inside a container port. Right? Okay. On the application of vision guided in particular inside container port. All right. Okay. And in terms of research, you can do vision guided biped walking, vision guided view vehicle, or view with a mobile robot, etc. Right. So these are some interesting research topic for those of you if you want to do research work in future. Right. Okay. Then how about the use of perception of audio signal in order to guide the robot or vehicle to undertake some useful action? Actually, you can do so, right? And the typical scenario is to make use of audio signal to achieve the control of a good enough for you to know. You see, through the use of audio signal, and in future, the vehicle can respond to the commands made by the driver and anticipate certain action, such as knowing where to go and start the heater, start the engine, start the lighting, etc. Right? Okay. So just now we have gone through these two typical category of skill-centric application, which could be enabled by AI system. All right. Now we move on to the highest level of intelligent mental activity, right? That should be the creativity-centric application, which could be enabled by AI. All right. So for creativity related or centric application, one is about the understanding of a huge amount of data, right? And the second one is to design a process, to design the product, or eventually to design a system, etc. So all these correspond to highest level of intelligence, which could be demonstrated by robot, by machine, or by human being, because for creativity-centric mental activity, it is also a challenge for human being to achieve as well, right? Okay, so if let's say we have a lot of data which may be related, then how to understand, digest the meaning or knowledge inside the data, right? Because the data could be created by another human being or by a group of human being, all right? Okay, and all these big data may come from a big system, and the big system, but always try to think when you see big data, behind the big data, there must be a big system, right? And the big system may refer to city, building, hospital, school, factory, or eventually big system may refer to the entire Earth, or big system may refer to entire solar system or galaxy system, right? So big data actually is a very hot topics, okay, very important topics, right? Okay, and then with the big data, first challenge is to try to discover the knowledge inside the big data. If we want to discover knowledge inside the big data, then the challenge is how to represent all this knowledge inside the big data. Again, it's very important for us to know how to represent knowledge inside the physical world, knowledge inside the conceptual world. Again, now you see this slide. So we believe that this representation of concept physical knowledge is extremely important in AI system, right? And this could be a very important contribution from our research, because this is proposed by us, all right? Okay, so it's a very important. And for a data-centric application, so we want to know, okay, the meaning or complex meaning inside the data, right? Because if you have a simple data or small data, it's quite easier for robot machine to understand the meaning. If you have a big data coming from the big system, such as a city, building, hospital, school, factory, then it is a challenge for AI system to understand the knowledge or meaning inside such a big data, right? Okay, so now I just quickly go through some example, right? Let's start with building. Okay, here you may want to know how come it is so important for us to pay attention to the development of smart building. Actually, this is related to another application scenario. People may be familiar with a vehicle. We may know, or some of you may heard of this car sharing, right? We can share the car we can share the bicycle, we can share the vehicle. And what is the motivation behind the car sharing? Answer is what? We try to reduce ownership, because to own a car is a big headache, yes or no? Because you need to maintain the car regularly and find the parking space to store your car. For example, when you have a car, you only use your car for 2 hours per day, for example, on average, right? Then majority of the time of your vehicle are sleeping, right? Then it's a waste. So therefore, people may want to know, can we share the car? Then we can also borrow this concept of a car sharing to other expensive items such as office, house, flat, etc., or factory. So therefore, in future, we may talk about the building sharing. Instead of a car sharing, we can talk about the building sharing. But always remember this prerequisite for us to achieve car sharing. We will talk about this issue when we study intelligent vehicle, for example, specific example, right? The prerequisite for us to achieve car sharing is to make a car shareable or to be intelligent, right? So similarly, if we want to make a future building to be shareable, the future building must be intelligent, right? Okay, now you understand why smart building is very, very interesting, because eventually it may trigger this commercial application of building sharing. Then in future, your life will be easier, because today to buy an office, to buy a flat, to buy a house is very expensive, right? Okay, so this is for you to know, okay? And okay, this video actually highlight a little bit to you the requirement of office.
Let us for you even so night, morning, afternoon, and so you get edge.
This should be good enough, right? But inside the video, you see, they do not know how to sell this concept of a smart building. Now you see, actually the selling point should be a building sharing. You never mention this one. Actually, it's mentioned by me, right? So actually, the selling point is building sharing. And when we talk about the intelligent vehicle, always remember the selling point is also car sharing. But today's car sharing is a fake sharing, because without the intelligence, you can never share your car. That is not car sharing. That is a car rentering. So we must differentiate what is a car rental and the car sharing. Same for building. The building rental, building sharing are two totally different concepts. I guess for all of you, if you understand this concept of building sharing, I guess this will help China to solve the issue of surplus of building in China. You see, today in China, a lot of buildings which are empty and expensive, right? Then people cannot afford to buy. How to solve this issue? We must promote this concept of building sharing. But always remember, a prerequisite of a building sharing is a smart building. But don't forget these 2 points, right? Okay, so this is very, very interesting, right? Building sharing. But in the video, they only talk about smart building. But these people, they do not know, okay? What is the commercial value of smart building, right? Commercial value of a smart building is building sharing. Similarly, commercial value of a smart vehicle should be car sharing, right? Clear? Okay. Then talk about the city. To a certain extent, we can say city is a shared city, journal. All of us live inside the same city, journal. Actually, city is a shared city, but people never mention that, journal. So this philosophy of sharing is extremely important, right? City by default is shared, right? Because city does not belong to a single person or belong to a single family, yes or no, right? It belongs to all of us, all right? Okay, so the sharing is very important. Then how to make city sharing to be more efficient, to be more beneficial to all the residents? Answer is what? We must increase the level of intelligence of city law, right? So then immediately you understand that AI is extremely important, which will make city sharing more convenient, right? More useful, more easier, more easily accessible, right? Okay, to all of us, and eventually to residents outside the city, right? For example, in future, if Beijing, Shanghai has reached a certain level of shareable city, then it's easier for me. For example, if let's say I want to make a decision to live in Beijing for 6 months, then I can do that, John. Today I cannot say I want to live in Beijing for 6 months, but it will be very expensive, John. I cannot buy a flat. If I live inside a hotel, it will be very expensive, John. Right? Okay. So this just help you to see in future, you can decide to live in London for 3 months or live in New York for 5 months very easily, affordably, right? Without paying too much money, right? Clear? Okay. So it will be
ways to into our in order to exceed expectations. Humans the solution Center for across interconnect citizen of operation were rare. Now visitors was since the beginning about issues, traffic signals, by creating some broadcast city bring citizens they control instant message. In operation is therefore work with to preserve and to out of services and the issue is long in operation from behind emergency that several find the response being a crowd and fire. Autumn Fire Department commission with along to quick assist law this be
Okay, so from the video, immediately you understand today people only see the benefit of making use of AI to empower the city leader, the manager of a city, or the manager of the building. But they never think about the benefit that the AI could bring to the user. So just as I mentioned, we must think both benefit, the benefit of AI to the city leader, city manager, but also the benefit of AI to the user of the city, all right? And the user of the city require the affordability, how to make the usage or the use of a city to be affordable. The only way to make the use of a city, the use of a building, or use of a car to be affordable is this idea of sharing. So we must focus on the benefit that the AI could bring in to the car sharing, building sharing, city sharing, all right? On top of the benefit to the manager, the leader of let's say city or building, okay, to empower their operation efficiency, etc. Right? And for hospital is the same. For example, how to achieve doctor sharing, because we may have an expert doctor in certain area, but this doctor maybe live in Beijing, but we may have a patient in Singapore or patient in Shanghai. They would like to gain the benefit from the expertise of a doctor in Beijing. This kinds of doctor sharing scheme, right? So AI eventually could also empower doctor to share his or her expertise widely on us, all right? So must think in that way. But of course, AI could empower the management or leader of a hospital to increase the level of operation or efficiency of operation of a hospital. Okay, so this is another area of making use of AI to enlarge the benefit of hospital. Right? Okay.
We are that's in a lab reality. What the everyone
Okay, this should be good enough for you to understand the AI integrated equipment, the AI integrated system will make a future hospital smarter, right? And this will empower doctor to undertake operation locally, and also empower manager of the hospital to manage the operation or activity of a hospital more efficiently. But again, they never think beyond that, right? So actually, with AI system, we can achieve a shareable hospital. All right, it's like a car sharing or hospital sharing, right? So in that way, you can always imagine the hybrid scenario. The doctor in another city just remotely use operation room in another city, all right? Then make the patient to benefit from the expertise of a doctor from another city, etc. Right? So that is a typical scenario of hospital sharing, right? So then empower or enable a doctor to share their expertise by other patient in other location, other places, etc. All right, so it's quite interesting, and the AI integrated sensor may also make the medical care more efficient. I guess this video highlighted a bit
technology supports it will the patient capability. Look, B2025. We will continue to unlock
So the previous video basically highlight to you the AI integrated sensor will help us to monitor our condition of health and then collect more data, okay, from our body, then make the treatment more efficient or something like that. All right. Then this is also another area of application of this commercial concept of sharing, right? How's about the school sharing? Because especially for university, we may have a very, very good professor in different city. How to make one city to benefit the teaching expertise and supervision expertise of a very, very good professor from other city, all right? So school sharing could be a solution, all right? So it means AI will not only enable the leader of the school, management of the school to manage a school more efficiently, but also create the benefit to the student through the school sharing, right? So that the school can gain access to the expertise of a famous professor in other city, other country, etc. Right? Okay. So it's very, very interesting. Smart school can be okay, good enough. And we can also like in the hospital environment, leverage on the AI integrated sensor to collect more accurate data or to collect the data in real time in order to improve the efficiency of healthcare. But in the smart school, we can also leverage on AI integrated technology to facilitate the professor, teacher to teach the concept and also help the student to undertake experiment more efficiently, right? Understand how to AI technology. And actually, it's very interesting for you to know, right? So the Tsinghua University has set up a medical school a few years ago, and the dean of this school actually was a professor from Singapore. And now you see when he lead this setup of medical school in Tsinghua University, and his philosophy is to design medical school with AI integrated courses, AI integrated experiment, instrument, etc. And basically, he wants the future doctor know or future nurse to master AI technology, AI knowledge, etc. Right? So that they will be more proficient in the use of AI integrated systems, software, device, equipment, etc. Right? So this just for you to know. Okay, actually AI will empower future school in any domain, all right? And this is just a new example which highlight to you about the AI integrated medical school, okay? So it's quite interesting for you to know, okay? Then for industry, I guess all of you may heard of Industry 4.0, right? Then you may start to think about what should be Industry 5.0. So Industry 5.0 should be robot integrated manufacturing. Then what is robot? Robot has a brain, robot has a mind, right? So to a certain extent, Industry 5.0 is also AI integrated factory, right? Okay, so you must think in that way.
Future look key process important. More to digital to connect all processes, not only in the company, but also this means the goal is all and able to connect but knowledge questions.
So you can start to think about the Industry 5.0. Just now I mentioned Industry 5.0 should be robot integrated manufacturing, and actually today we are quite close to achieving Industry 5.0. So you watch this video. Okay, so from that video, then you see we are quite close towards achieving the scenario of Industry 5.0, right? Okay, so with the big data, then from a big system, eventually we can increase the level of intelligence and increase the efficiency of operation of a big system. But in particular, we can achieve the scenario of shareable big systems such as car sharing, building sharing, factory sharing, school sharing, hospital sharing, and city sharing, all right? So think in that way, then you will see the huge benefit that the AI could bring to our society and the industry, all right? And then the second category of creativity-centric application should be the design, right? Design may means design of the product, design of a system, and eventually composition of music, etc. Right? Okay, and strictly speaking, if you talk about the manufacturing, manufacturing actually include three important phases as well: design, production, and marketing and the sales. So you will see, and in industry, design is one necessary process, okay, for manufacturing. All right. So for the design of the product, eventually AI could enable us to capture the specification of a new product. Okay, but the specification of a new product could be described in the form of a text or drawing, or the user just use a gesture to highlight the desired feature of the product. Then the AI system could understand the product specification, then based on the product specification, then come out the preliminary design prototype. Then the human designer just do a fine-tuning of pre-designed prototype by AI system. This could be the future scenario for us to make a transition from today's computer-aided design to computer design. So for those of you with mechanical engineering knowledge, you know this term now, CAD, computer-aided design, right? So then what will be the next? The next should be computer design, all right? So achieve computer design, all right? Okay, and then we can apply AI theory, AI technology to help us to design mechanical product, medical product. Medical product is a drug, right? And eventually we can also design a system or large systems such as a factory, school, or eventually a city, or public service system, etc. Right? So this is a very, very important and challenging application faced by AI. Then for product design, today more or less we know the procedure, right? So if let's say we want to have a smart robot as a product, and based on the diagram of the function to be performed by this robot, then we can identify the module or individual subsystem to be included inside the robot. Then for each module or each subsystem, then we can identify what are the possible solutions for us to choose. Then we come out of this matrix or this table. Then with use of this table or this matrix, we can choose a different type of a combination, right? How to combine all these different options together, right? Then we come out the design solution, ABC. I just show 3 examples. Then we can rank these 3 design solutions according to the cost, the stability and the reliability and the outlook of the product, etc. Then after ranking, the different possible design solution according to the cost, reliability, and the complexity of doing manufacturing, etc., appearance, etc., right? So we can rank them, then choose the one which have the highest score. Then based on that, selected the best design option. Then we come out the 3D drawing, then the part drawing form a relationship tree. Then for each part, then we can make a decision whether to purchase or to produce in-house, right? So then we have a logistic, etc., right? Okay, so today in the industry, we have a but just highlight then you see right? We have right? Combine light easily it should be good enough for you to know, right? But eventually, we can also apply AI technology to compose a drug or compose medication. For example, for traditional Chinese medicine, all right? And this is a proposition made by me, right? So we can apply AI technology to traditional Chinese medicine, right? To leverage on the use of AI to compose medication or drug, okay? According to the theory or principle of TCM, traditional Chinese medicine, all right? Okay, so this is a very, very interesting application. Then we can also eventually design a factory, all right? And design a production line. And the good news to you is we have a software tool which allow us to
it's all to stay not need to evaluate. It's to sales included in factory and make floor targeted towards the specific needs of builders, integrators, providing another the contain together. Yeah, it's also other cases. As easy as possible. Develop your factory as easy to the certification board. Process allows all so the best solution is found. Counterproductive consequences. Be added to reservations.
This should be, due to time constraint, should be good enough, all right? So eventually we can apply AI system, AI technology to help us to design a better school or better social system, etc., right? For example, you know, in social science, not many students, not many school will teach control theory, all right? So that is a very, very, okay, bad situation to the entire world, right? Because feedback control theory is very, very important, not only for engineering system, but also for social system, all right? And the lack of knowledge about the feedback control system in social science make the whole world suffer every 10 years because every 10 years periodically we have financial crisis, economic crisis, okay? The reason is because in the whole world, economic system, financial system are being operated in an open loop manner, which is not the stable system. All right. Okay. So this just help you to understand. Okay. In future, AI could help us to avoid such a mistake or such a negligence about the importance of control theory. All right. Okay. Okay. So let's talk about today's study. In today's study, basically, we have learned three major group of application. First group refer to knowledge-centric application which are enabled by AI. Second group of application refer to skill-centric application which are enabled by AI. And the last group of application refer to creativity-centric application which are enabled by AI. All right. So by now, you can try to link today's lecture with the previous lecture. So you understand the first group of application actually help us to strengthen pillar number 2 in AI 3.0, right? Then the last group of application actually represent the highest level of application which could be enabled by AI, okay? We more or less reached the time for today's lecture. But anyway, I thought to have a few minutes to undertake a short session of Q&A, right? So now you are welcome to ask a question, right? You can type your question or you turn on your microphone, then we can, okay, have a conversational dialogue, okay? Or anyone would like to, I don't know whether there's a, sure. Okay, good. Yeah, that is a comments. Okay, if you, for those of you, if you want to share your questions, share your comments, all right? So you can type inside the chat window so that the other student will know your question. Then can learn from your question or your comments, all right? Anyone would like to share your question? Or you can also ask a question which are related to the previous lecture, right? Not necessary to this lecture, right? Any question? Okay, try to learn how to, okay, raise a question, ask a question.
Okay, if you have no question.
If no question, then we end today's session, right?
Yeah. Last, I would like to emphasize our assessment requirements again. Wait a minute.